Technology changes the way we live and work. Technology also plays a major part in the rapid increase of biological knowledge. Until the late 1600s, no one knew about cells or single-celled organisms. Then the microscope was invented. The microscope was the first in a long line of technologies that have changed the study of biology. A microscope provides an enlarged image of an object. The first microscopes magnified objects but did not produce a clear image. By the 1800s, most microscopes had a combination of lenses that provided clearer images. Today's light microscopes are still based on the same principles. Light microscopes clearly magnify specimens up to about 1,500 times their actual size, and samples are often stained with chemicals to make the details stand out. Electron microscopes, developed in the 1950s, use beams of electrons instead of light to magnify objects. These microscopes can be used to see cells, but they produce much higher magnifications, so they can also show much smaller things. Electron microscopes can clearly magnify specimens more than 100,000 times their actual size. A transmission electron microscope transmits electrons through thin slice specimen. The TEM makes a two-dimensional image similar to that of the light microscope, but the TEM has a much higher magnification. We'll now take a look at the light microscope and all the components that make up for it. At the top, we have an ocular lens. This is the part that we look through. It's also called an eyepiece, and usually its magnification is 10 times. Below the ocular lens, this is a tube, and we have the revolving nose piece. This piece here is able to turn, and on it are the objective lenses. Usually there are 3 or 4 objective lenses, and each one has a different magnification. I'm pointing to the arm, which connects the base of the microscope to the upper part, which is called the barrel or the tube. The specimen will sit on the stage, and there are usually some metal clips here that will hold the slide onto the stage. Underneath, there will be a dial that will regulate the amount of light that comes through, and the light source is usually from a light bulb that's at the bottom on the base. We'll have a power switch and a cord to plug in, and most importantly, we have these 2 knobs on the side. The larger knob is the coarse focus knob, which raises the stage up or down and is used for focusing. And then beside it, there will be a smaller knob that moves just slightly and provides the clarity of the image. In order to calculate the total magnification, we need to multiply the ocular lens, so usually 10 times, by the magnification of the appropriate objective lens. So usually the smallest lens is 4, and then it goes 10 and 40, and if there's a 4th one, it's usually 100. So calculating the magnification when we are on the lowest objective lens, lowest power, we are going to go 10 times 4 equals 40. The object we are looking at will be 40 times larger than normal.
Neat. Oh, dear Tim and Moby. How does a microscope work? From Quincy. Well, there are lots of different kinds of microscopes. The most common are light or optical microscopes, like this one. It uses visible light and 1 or more lenses to magnify very small objects. A lens is a piece of glass or other transparent substance that's curved to bend light. Depending on how it's made, a lens can make objects appear bigger or smaller. Light microscopes magnify small objects with a combination of convex lenses, which curve outwards, and concave lenses, which curve inwards. It all starts with a light source. Light is either projected directly through the lens or bounced from a mirror mounted underneath the microscope's stage. The stage is a platform with a small hole in it. Light comes through the hole and passes through a thin slice of the specimen you want to magnify. The specimen is mounted on a slide, which is a rectangular piece of glass or plastic. After passing through the specimen, the light hits a series of objective lenses, which form an enlarged image of the specimen. The light from the objective lens set moves through the tube to the eyepiece. There, the image is further enlarged by the ocular lenses. No, that's not all there is to it. The image might still be out of focus. Knobs that move the objective lens set closer to and farther away from the specimen focus the image. The coarse focus knob makes big adjustments to put the specimen into general focus, and the fine focus knob makes smaller adjustments. Oh, and that piece of curved metal that connects the stage to the tube? That's called the arm of the microscope. And the heavy piece of metal it all rests on is the base, which keeps everything stable. The optical microscopes we use today follow the same basic design of the first compound microscopes, invented sometime around 1600 in the Netherlands. An inventor named Anton van Leeuwenhoek made the best microscopes in those early days, so he's known as the father of microscopy. But lots of inventors were building similar instruments around the same time, so it's not clear who made the very first one. Yeah, light microscopes are just the simplest kind. Another common type is called an electron microscope. These microscopes use a beam of electrons to produce really high-resolution images. They can magnify much smaller objects than optical microscopes because the electron wavelengths are much smaller than those of visible light. A third category of microscopes is scanning probe microscopes. These microscopes use an extremely fine point, sometimes a single atom wide, to see individual atoms or molecules on a material's surface. Well, all these high-tech microscopes can be used for lots of stuff. Anything from looking at grains of pollen in amazing detail to checking out the atomic structure of a certain material. Hey, I think my frozen pizza's burning. I'll be right back.
Do you mind?